My equation for the YouTube video project was m of x equals 5x squared divided by x plus 1 minus 3x divided by x minus 1 plus 7 divided by x minus 1. And so to solve this problem, you would first multiply 5x squared divided by x plus 1 by x plus 1 over x minus 1. So the x plus 1s would cancel themselves out, and you would be left with 5x squared divided by x minus 1 minus 3x divided by x minus 1 plus 7 divided by x minus 1. And when you combine all the terms, because the denominators were made equal to each other, making the addition and subtraction possible, you would get 5x squared minus 3x plus 7 divided by x minus 1. The graph of the equation would be as such. When the x minimum is -5, the x maximum is 7, the x scale is 1, the y minimum is -100, the y maximum is 100, and the y scale is 20. Yeah. There were no holes in the equation. There was a horizontal asymptote at x equals 1, or there was a vertical asymptote at x equals 1. There were no horizontal asymptotes. The y-intercept was -7. There was no x-intercept. Some other points on the graph that could make it easier to comprehend were 3/42 over 3, or 42 over 3, yes, sorry, 2, 21, and -1, 15 over 2. Some possible pitfalls during this were thinking that there was an x-asymptote and trying to solve for that when there was in fact no x-asymptote. The method I used in the beginning for finding the least common denominator was multiplying one term by another term in order to get a term that was equal to the rest of the denominators. Another area it was possible to make a mistake was to multiply the whole equation through by by x minus 1 over x plus 1, which would give you a very wrong equation. I ran into the confusion of being convinced there was an x-asymptote when there was not, and I fixed it by looking at the graph on a calculator. One of the things unique about my function was when it was graphed, the lines would approach the origin, and then once they would reach the origin, they would go away from the origin. You can see this happens with both. The final graph looks like this and makes sense given the tools I had. Thank you.